Okay, so if we were only to spin and land on blue, we could get either a 1 to go with that, a 2, or a 3. If we were to only spin green, we could either get a 1, a 2, or a 3. If we were to spin a red, we could get a 1 with red, a 2 with a red, or the number 3 with red. And if we were to only spin yellow, we could get a 1, a 2, or a 3. So when we count our outcomes, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. So we have 12 possible outcomes. All right, so the key idea of this. So those are just ways that we can organize how to come up with all of our possible outcomes, except that sometimes it's not always possible to list out, or time efficient, I guess, to list out every single possible outcome. And so we're going to go over a way that's a little bit faster now. So first, let's look back at example 1. When we had example 1, we had 2 choices of bread. We had 4 choices of meat, and that gave us 8 total outcomes. In example 2, we had 6 possible outcomes when we rolled our die, numbers 1 through 6. And then we had a coin, which gave us 2 possible outcomes because you could either get heads or tails. And that gave us 12 total outcomes. So with the spinner, we had 4 possible outcomes. And then we had 3 numbers that we could choose from. And that gave us 12 possible outcomes. So what do we notice about this? We can see that 2 times 4 gives us 8, and 6 times 2 gives us 12, and 4 times 3 gives us 12. So this is called the fundamental counting principle. We shorten that to FCP. And this can be used to find the total number of possible outcomes of a compound event. And a compound event just means that we have multiple events at the same time. So the FCP says that if one event has M, because we don't know how many outcomes, and the second event has N number of outcomes, the total number of outcomes for the first event multiplied by the second event is going to be M times N, which will give us our total number of outcomes. So let's use this. So using the FCP property, how many different outcomes can you make from the t-shirts, jeans, and shoes in the closet? So event 1, if we look at the t-shirts, we have 1, 2, 3, 4, 5, 6, 7 possible outcomes. We have for pants 1, 2, 3, 4 possible outcomes. And for shoes, we have 1, 2, 3 pairs of shoes. So this means that I can just multiply all of those together. So 7 times 4 times 3, and that's going to give us 84 different outfits. So that means that you can wear a different outfit for 84 days straight before you have to repeat them. And even if it's might be like the same shirt with the same jeans, you can wear a different pair of shoes. That's what that's saying. So there are 84 different combinations that you can have. How many different outcomes can you make from 4 t-shirts, 5 pairs of jeans, and 5 pairs of shoes? So we are just going to multiply all of those together. And so I'm going to have you do that, and then you can check your answer with mine in the next video.